So welcome to the research track session 4 on modeling support and maintainability. So this session is chaired by me, Artem Poliviani, and Stephanie Rinderle-Ma. We have an exciting program with 4 papers lined up to be presented. And we plan that each paper will be presented for 12 minutes, followed by 5 minutes of questions and answers. And I will keep track of time very closely. And if I show the watch, it means in the video, it means that we are approaching 2 minutes of last minutes of 2 minutes of presentation remaining. So dear attendees, please forward your questions through Zoom, right? So not through the app, but through the Zoom chat and the Zoom question and answer function. And now Adela will play us also a video, as she promised us.
Yes.
Adela, please.
I'm going to do. I'm sharing my screen. Can you see my screen?
Yes.
Okay.
You can see behind us the Cathedral of Sevilla, which is a UNESCO World Site and finished in the 16th century. Local tradition has it that the cathedral chapter, when they started building it, said to each other, let's build something which is so grand and beautiful that whoever sees it finished will take us for mad. And indeed, it is quite spectacular. So the cathedral is the largest cathedral in the world. And even though St. Peter's Church in Rome is bigger, it's not a cathedral. So they earn the right to say so.
But there are also many people buried inside, including Christopher Columbus. And something really nice to see is the courtyard called Patio de los Naranjos, which is full of orange trees. And also it has a fountain in the middle of the square. And the way to get to that courtyard is through the door, the lizard door, or Puerta del Lagarto. And it takes its name because you can see still a crocodile hanging from the side. So there is a nice story behind this crocodile, and I think you should look it up. That's all. So now you can go on with the session. Thank you.
All right, enough teasing us. Adela, now you need to promise that you will organize another conference in Sevilla and we'll be able to come and see that cathedral. So let's jump immediately to the program. So the first paper is entitled Looking for Meaning, Discovering Action Response Effect Patterns in Business Processes. And this is a paper co-authored by Jelmer Koorn, Shishilu, Henrik Leopold, and Hayo Ryers, and the presenter is Jelmer Koorn. Jelmer, the floor is yours.
Thanks, Artem. Yeah, so I'll be presenting our paper, Discovering Action Response Effect Patterns, on behalf of the team, and we're very happy to present it at BPM. It's also my first time, so I'm very happy to be here. Let's see, yes. So the content of the presentation quickly. I'll start off with sketching the context, after which we go into the problem statement. And there we can obviously identify the challenges that we face, and then also see the proposed solution that we put forward in the paper. Then, of course, I'll tell a little bit about our case study. And the most interesting part of the presentation will be applying our proposed solution to this case study. And if I have time, which I'm afraid I will not, but we'll go into limitations and future work that we're already working on. So if we talk about action response effect patterns, it's easiest to explain this by an example. And the example is our case study. So that's the context that we will be looking at. This is a case study in the healthcare domain. Clients are in residential facilities, so protected communities. They live there 24/7. And they have intellectual disabilities, and sometimes these clients get aggressive, and that's what we will be looking at in this presentation. So our first action is that there's an aggressive incident from a client, and this can be one of many. So it could be, for example, that the client starts hitting someone else, either a caretaker or another client. But it could also be that the client breaks something like a phone, so that would be physical aggression towards objects, or he could simply start shouting very aggressively, so we would call that verbal aggression. So that's the first part of our triplet action response effect. So on these wards, we obviously have caretakers. And these caretakers see this aggression, and they probably will decide to intervene in some way or another. So that's the response. This again can be one of many as well. So it could be that the caretaker decides to talk to the client and give them a verbal warning. They could medicate the client, which is more done in the US, for example, but they could also decide to put them in an isolation cell, which are present at these facilities. So after this, this has taken place, we have the action, which is the aggressive incident, and response, which is the intervention. The nurse or the caretaker records this in a form, and this is all dumped into an information system, which is obviously where we get very excited and we start doing things. So to quickly wrap this part up, we have an action response pattern now that we're interested in. The action is the aggressive behavior of the client. That could be, for example, verbal aggression, and then a caretaker sees this and they respond in a certain way, which is the response. So the intervention could be, for example, seclusion. Another example could be that the client starts hitting someone, so that's physical aggression towards a person, and the caretaker observes this and they reply by, or intervene by talking to the client. Now this is all very nice, and we can convert this to something that is a little bit more familiar to what we know in the BPM field. So that will be an event response log that we would be looking at. So we have an event ID, a client ID, timestamp event, which is the aggressive incident, and the response, which is the intervention of the nurse. Now on the right-hand side, you can see that we can convert this to a DFG graph. Why is this interesting? So one of the questions that we could have in this situation is that we're interested in how the behavior of the client develops. So we could see from the DFG graph on the right, we could see, for example, that after a verbal aggressive incident of a client, in one case, the same type of behavior repeats. In two other cases, we see that it goes to the one below that, and that's it's the physical aggression towards an object. And we can even see that in one case, it escalates to physical aggression towards another person. So when we go from verbal aggression to physical aggression, we always talk about escalation of violence, and the other way around, we talk about de-escalation. So this is interesting in itself, but it does leave a question that we could not answer, and that's where we came in with our research that we bumped into, and that is, what is the effect of what we're looking at? So we're not only interested in how the behavior develops of this client, but we're very much interested in why it develops. So in our case, if we look back into these two cases that I previously pointed out, we're interested in the effect of the response of the nurse on the action and whether or not that affects the next iteration of that incident. So to come back to this example, if a client shouts and the nurse responds physically by putting them in an isolation cell, it could be that the client thinks next time he or she becomes aggressive, I might as well become physically aggressive because the incident is going to get physical at some point anyway. So they might start off by hitting someone to start with. So this is what we would call escalation of violence. Now, these are questions that we are very interested in our industry partner as well. But we run into a couple of problems when we try and look into this. The first problem is that the graphical representations that we have now do not really help us in gaining the insights that we have. So we already saw the DFG next to this on the right-hand side of the slide. We see the PetriNet. So what you see is that we actually have a one-to-many relationship. So we have a choice for an action, which is one of three. And then we have a choice of a response, which is also one of three in this case. And then what we're really interested in is how the combination of those two affects the next iteration of that same choice realm. So that's something that we cannot do currently. And another thing is that you can imagine that we only have three choices now, but once we start adding choices, this graph starts exploding and it becomes less and less easy to gain the insights that you want. So wrapping that up, we have some challenges, which I pointed out on the left-hand side, but our proposed solution is to move from the current techniques towards more statistical techniques. So what we're really interested in, if we're looking into this question, is we are looking into the dependency relations that are amongst these triplets. And once we start looking into this, we can actually also filter them quite easily by looking into the statistical significance of these relations. So we can filter based on those criteria. So this is a bit vague, and in the paper we go into great detail about the statistics that we actually use, but for this presentation I want to focus more on the conceptual point that we're trying to make in the paper. But I'll briefly tell you a little bit about the statistics that we use. So we basically use a three-step method where each time we drill deeper into our triplet and find out more. So we also move chronologically through the graph, so to speak, where we first start with high-level statistics and we identify the interesting actions, so the interesting nodes to draw for the actions. Then we drill into the responses that are interesting given the action. And finally, we identify influential points, which is really the last part, and we sort of complete to look at the exact triplet that's interesting, and we use some post hoc testing to identify specific response effect patterns that are of use to the user. So then a little bit about the case study before I can actually get into the interesting part. So it's in the healthcare domain. I already explained this briefly. We have 3 years of observational data spanning almost 22,000 incidents, all recorded in an information system that we extracted, and it spans over almost a little over 1,000 clients. So it's really quite interesting to us. But before we get into the actual case study, maybe a quick reminder. I'm going quite fast, I know that. So the key question that we're trying to answer here is how a response to an action can lead to a desired or undesired outcome. So that's the effect. And remember that a desired outcome would be de-escalation of violence, and an undesired outcome would be an escalation of violence. Now, the example that we look into is aggressive behavior towards objects. So an escalation of the violence would be aggressive behavior towards a person, and de-escalation of violence would be verbal aggression. So let's take this data, we do some pre-processing, so I'll explain. We can see and we make a DFG. So we use Disco here, and we filter on 5% of the paths and activities to make it interpretable. We see in the top right corner, we see, for example, dark blue, we see the initial action, which is physical aggression towards objects. And let's go down the left path that we see. And we can see that one of the responses is that there is no response from the nurse. So the nurse observes this behavior and decides not to intervene. And if we go a little bit more down all the way to the bottom, we see that the effect of this in some of the cases is that there is no next incident. So no next incident is recorded for this client. So this will be a very desirable outcome. The problem, however, is that we do not know what these numbers mean. Is the 11 that's on the last arc, is that good or bad? Is that a lot or is that not a lot? Is that what we expected? And this is where statistics come in. We can actually determine what we would expect based on statistics if we have an unequal data set, and we can see if the observed number differs from this expected number, and that is what is really interesting. So that's where our technique comes in, and we would do the same for the same problem. So again, in the top we have the physical aggression towards objects. Then we draw arcs to 3 of the responses that have interesting dependency relations. So terminate contract on the left, seclusion in the middle, and distracting client on the right. And then comes the statistics part that we actually show in our approach. On the bottom, you see the first number you see is the observed number, and the second number between brackets is the number that we would expect based on the statistics that we perform. So you'll see a thick arrow when we observe more of the behavior than we expect, and you see a thin arrow when we see less of the behavior than we expect. So if we look into terminate contact, how can we interpret this? It's maybe a good question. So if there is a physical aggression towards an object, and the caretaker responds by terminating the contact, we see more of verbal aggression than we would expect. So this is a desired outcome, right? So it de-escalates the violence. In contrast, in the middle with seclusion, so if the response of the nurse is to seclude the patient, we can see less of tau, which means we see less of no next incident, which is a bad thing because there's more often an incident we would expect. And in addition, we see more of a de-escalation of violence, so physical aggression towards people. So these are both undesired outcomes. So this intervention leads to an undesired outcome, or effect, I should say. And the last part leads to more repetition of the same type of behavior, which is a completely different strand of research. So given time, I cannot go into detail, but this is the concept that we're trying to carve out in our paper. There are some limitations in future work. I promise this is my last slide, Artem. So we have some work on the assumption of independence of responses. This is now done manually. And one thing that we're looking into is automating our approach a little bit more. Obviously, we have limited generalizability, which is a pity. We would love to apply this to more domains and see if our approach works there too. And finally, we would really like to relax the concept of effect. It's the definition that we use now in the formalization is a little bit strict, and we think we can relax it so it becomes more broadly applicable as well in these other domains. So with that, I would like to leave you. Thank you for your attention. I know it's hard in these online times. Here are some code. You can find our code online as well. Yeah, any questions, feel free.
Thank you, Hjalmar. Let's thank the speaker virtually through virtual applause and all the co-authors. Thank you, Haya. So let's move to questions. Do we have any questions coming from the Q&A or the attendees? So if you have a question and you want to speak up, you please raise your hand, virtual hand, in the participants list, and we will unmute you. Or type your question in Q&A function, using Q&A function of the chat. So there is a question.
There's a comment. There's a comment in the chat by Thomas Hillebrand. I don't know if he wants to tell us. Let's find him.
Also,
Martin, can you find him?
I can see a question from Luis Pablo.
Maybe we can start this and do this then later.
Yeah,
I try to find him.
I will unmute Luis. Can you speak?
Yeah, sure. Thank you.
Thank you.
I find this very interesting. I was just wondering if you have related this to automata learning. Do you think this is a very typical scenario in machine learning when you have a sequence of something and then you want to learn a model that explains this, like typically it's a statistical finite state automata or maybe even a context-free grammar, but there are lots of works, some more theoretical, some more applied, but that are algorithms able to infer these relations of if the history of the recent history that has happened has this shape or this distribution, then the foreseeable future will have this probability in this case or this order.
Thanks for your question. Yeah, so definitely we are looking into machine learning as well. One of the things that we really run into when we use machine learning, so we did a master project with that, and we noticed that the explainability is just extremely difficult. So the statistics that we use are actually very easy and very straightforward. Well, easy, I shouldn't say, but basic maybe. So if we explain our results to the people in the organization, it becomes much easier because we can show exactly what our calculations are and where our numbers come from. And this is just a little bit more difficult if we use machine learning. And people find it a bit scary if we say that we use machine learning. We noticed also in the organization. So we're looking into it, definitely. And I think what is the big advantage of machine learning is that we'll get more precise results than we have now. But the disadvantage is that it takes away from the explainability that we can have. So yeah, that's the sort of the balance that we're looking into.
Thank you for question.
Okay, I found Thomas. I try to unmute him. Thomas? Thomas, can you hear us?
I think it doesn't work. Maybe I can make a question. I have a question. So you showed us the DFG somewhere early in the slides, around slide 6, and that one contained actions, but not responses. Or maybe correct me. So right. So in this event log, you have also responses.
Yeah.
So how? And then later on slide 14, you showed DFG where you also have responses. So how do you identify responses in your event logs?
Right. So this is all structured data from the forms that we collect from the nurses. So we can actually just infer that from our data. This is the other one you mean, I guess, or you mean the disco graph that we showed?
Or
this one.
All right. So this one already contains responses as well.
Yeah. Yeah, so the first one is really just to show the problem. Here we did more pre-processing. We added the responses because obviously you can expand this DFG with responses and effects. So that's what we did here, but you still do not get the insights of the why, right? So the way that we infer it is just it's basically a column in our data. It's given by the nurse, and then here. We can differentiate that, but the problem is, if you expand this DFG in this way, is that the numbers lose their meaning. They only show frequency, and frequency is not always a good indicator. For example, very few cases we see result in a response that is isolation or seclusion. So if we start filtering based on frequency, we would filter out most of these interactions, whereas in reality, it might be really interesting to look at these things purely because the effect that comes after might be more or less frequent than we would expect. I don't know if that really answers your question.
Yeah, this goes into that direction. I propose that maybe we discuss later offline. There is also another question from Hugo who wants to ask a question. I also propose that that one is discussed offline. So just maybe ask the question, Hugo, in chat, and the authors will reply, or in one of their coffee sessions.
Yeah, I'll be there tomorrow morning for sure.
That's fine. I think I already wrote it to the panelists in the chat, so we can take it offline if it's a question of time.
Yeah, we need to move to the next paper. And if you have questions, just type them during the presentation, right? So that when the presentation finishes, we immediately can start with questions. So the second paper of this session is extracting annotations from textual descriptions of processes. This is a paper by Luis Quishpi, Joseph Carmona, and Luis Padro. And Luis Quishpi will present this paper. And Luis, if you're ready, please start.
Sorry, I'm sharing right now. Do you see?
Yes, very good.
Okay. Good morning, everyone. My name is Luis Quishpi from Universidad Politécnica de Catalunya. I'm a PhD student. Today, I'm going to talk about the extracting annotation from textual description of processes. This research aims to automatically identify and extracting from a text the main elements that are part of business process model, such as conditions, events, tasks, and also the different relations that may exist between them, such as sequences and conflicts. As we know, today many organizations have several sources of information that is talking about the processes. Of course, ideally it will be the first one. That is the formal models such as BPMN or DMN. But in practice, organizations document their process in different ways, such as textual descriptions, checklists, rules, and guidelines. Then the goal is to align this information so that all the roles involved have the same expectation about the process. In this research, we automatically extract the annotations that could be used by some annotation tools. For instance, the one behind the model judge or process highlighter. Our approach is based on applying NRP to the input text. In particular, one of the main elements that emerges from the NRP is the dependency tree. The dependency tree is the basic elements on which we build our proposal. Here is an example of a sentence and its corresponding dependency tree. As we can see in the graphic, dependency tree shows in a hierarchical way the relation between the different elements of the sentence. In this case, for instance, we can say that the sign node is child of the if node. In this term, it is child of the orange node, and so on with the other nodes. In this work, we use TREGEX. TREGEX is a query language that allows the definition of regular expression like patterns over tree structures. In the table on the left is a list of basic TREGEX operators that we have used. The idea is to apply TREGEX patterns to a dependency tree that allows us to search the complex dominance relation of labeler trees. For instance, the pattern number 1 is correct or matched with the tree since node E is dominated by the node A. And in turn, this node A dominates node G. And the same way, the pattern number 2 matches with the tree since node E is dominated by the node A, and it is the only child of the node B. The regex patterns also allow us the capture and node variables. In the pattern number 2, node A is stored in variable X and the node B is stored in variable Y. Those variables can also be used in other relations in the same pattern. The technique we propose automatically extracts the HTTP elements by applying T-regex patterns on the dependency tree. When a certain pattern is matched, a particular element of the definite process is identified and extracted. Therefore, the core of our contribution is the defining of the patterns for each element that we want to identify. The final result is a set of HTTP elements that can be used to get formal representation of models of processes. The HTTP format, as a result of our techniques, is just an example, as it could be used to directly generate a BPMN or DMN as well. Hence the importance and the potential of our technique. The main step with the NLP analysis is the labeling of the certain nodes as action. As an NLP parser, we use threading, and one of the steps that this parser performs is semantic role labeling, where among other things, it generates predicates, which are related to actions. Then, taking those predicates, we proceed to label as action each of not the correspondence tree. To extract the condition, we first identify some keywords that identify condition clauses. For instance, in the slide, we have the if conditions and the weather. In the first example, the pattern is interpreted as the verb node is the first child of the if node. If the condition is met, the node captures in the variable result is labeled as condition in the dependency tree. In the first graphic, we can see that the sign node is the first child of the if node. Therefore, the sign node is labeled as condition. The second pattern as condition, the node labels as condition the node that is the first child of weather. That is the node B in this case. With the third pattern, we label the node that is the first child of OR, but that the OR node is dominated by weather. In other words, we label the node need as condition. After applying the patterns and labeling the node's conditions to make the conditional phrase, we take all of the subnodes from the nodes labeled as condition. In our first example, the conditional phrase will be the patient signs and informed consent. Well, to extract the tasks, we apply 4 patterns. The first pattern simply discards uninformative verbs like be and have as activities. Subjective verbs like want, think, and believe are unlike to describe activities and thus are filtered out with the second pattern. In the third and fourth pattern, remove any actions candidates that are in a subordinate clause under another action. The idea is that a subordinate clause is describing details about some elements in the main clause, but it is not relevant activity. Thus, it must be removed. For instance, in the example sentence, the verb select would be removed as activity, since the main action is update. To extract the events, we use similar patterns and procedures. We also use patterns to capture a relation between the previous detected elements, such as response and precedence. The first pattern captures the case where condition is inside an if clause, which has an activity as the condition's consequent. In this case, it's safe to assume that the activity responds to the occurrence of the condition. For instance, in the dependency tree, the first pattern will extract the arrange activity response to signed activity, to respond to sign. With the second pattern, we are able to extract a sequential relation between event and activity. Note the typical case of precedence. To carry out our experiment, we follow two steps. First, from a human created model, we generate a gold standard annotation. For this, we use the model judge annotator. To get the results, we run ITDP extractor tool and compare these results with the gold standard annotation that was obtained previously. As we can see in the table, the obtained results show that the baseline in column 6 obtain higher recall since it extracts more activities, but lower precision since many of the extracted activities are not in the gold annotation. That is, they are not relevant for the process. The baseline are the regex patterns that emulate the behavior of the Friedrich system. On the other hand, our approach is a bit more conservative and extract less activity, thus getting slightly lower recall, but higher precision. Overall, the trade-off F1 score is better when using our based pattern. Similar to the previous table, this table again shows the tendency to improve the results for the extracting the relations. To conclude, we have presented a novel techniques for extracting annotation from textual process description. When comparing the technique with the baseline, a significant rise in precision has been obtained. As future work, we plan to extend this approach in order to capture other relations and improving the existing ones, but also use supervised techniques to learn automatically new patterns so that the system is more autonomous. That's all. Thank you so much for your attention.
Thank you, Luis. Let's thank the speaker. I propose that we start with questions from the audience so that we have enough time to answer them. Let's prioritize audience questions. So please, if you have a question, raise your hand in the participants list or type a question in a Q&A function of the Zoom. Stephanie, there is a question from Henrik.
Yeah, he's raising his hand. Yes.
I'm not in the audience. Well, technically, yes. Yeah, so thanks for the presentation. So I like the idea of using, so to say, querying this tree. I was still wondering, I think, well, you partially answered the question on your last slide. I think in the end, you're still having heuristics, right? So, I mean, there is a dependency tree. What you basically have to configure is to, well, all the, you have to pre-configure the queries, the patterns that you're expecting. So I was wondering about how flexible this can be, and and how potentially overfitting this is on the data set that you have been looking at. So maybe you can comment on this.
Yes. Of course, the first time to create the patterns is not very easy, but after to the first one, we can make the patterns, and the pattern is very flexible. We can combine it with the POS or the verbs, etc. As you can see in this slide, for example, the if is only the name, and we can combine it with the preposition, the verb, and other words, and then the tree is very flexible.
But you would need to define these things in the first place, right? Yeah.
Sorry?
Yeah, but you would need to define these things in the first place. So it's like I think Hugo was pointing out the same thing. It's a rule-based approach.
Yeah, and we can find
Of course,
the
all these have to be predefined manually, right?
Sí, dile que sí.
yeah, yes.
Te pregunta si son muy específicos los patrones.
Yes.
So if I may, yes, there is a risk of overfitting, because of course you need to hand write the patterns, and there is the risk that you handwrite it in the to tailor for the development data set. But the idea is that we try to write general patterns with some kind of linguistic insight. So if you know that there is a subordinate clause that has an if, and that tree will, in general, if the parser is right, will always have that shape when there is this kind of clause, then the patterns should be general. But they are, of course, are heuristics. Yeah.
There's also a question by Hugo.
Yeah, let's give Hugo a chance to ask his question this time. Hugo, please.
Thank you very much. I think it's a great work. Thank you very much, guys. I have a question more regarding generality of the kind of the approaching here. So, like, there's a question in parsing in general. Is that when you have different patterns that match the same sentence? In like, typical question is a if then and an if then else. And so what kind of strategies do you apply here for subordinates? And the other question was more like, if I move away from process descriptions to other domain, like as you mentioned, you have guidelines, or you have law documents, you might have a different type of patterns there. For instance, how do you map ought or shall to one given type of constraint? Have you explored these domains as you mentioned in your introduction?
Yeah, the first question was about the condition, right? You can make the different patterns if you have the condition. For example, in this slide we have the patterns for if and for whether, and in this case, first, if we match two patterns, of course, we can discard the second pattern. It's only the function of the tools. And the applying is in cascade, because first discard first one and second one after that. That is the idea. If the first pattern match and the second one is not, it's another problem. Yeah, and the second question was, please could you repeat?
So basically, when you, like in your introduction, you have something regarding process descriptions, but other domains as well, like guidelines, a checklist, and the like. And I would argue that for each of these domains, the writing style is different. So when you have a law, most of the dependencies come after and not before. So when you apply your pattern matching, you're reading and you're comparing to the information you have backwards. So for that, an LSTSM approach is not really good. But when you start looking at other domains, that might not help you. So I was wondering whether if you have been looking at these other domains that you mentioned, like checklists and guidelines, and how was your experience on that?
Yes, in this case, we should create the different patterns for the. But in this research, we didn't put right now.
Okay, thank you.
All right, let's thank the speaker one more time, and let's move to the next paper. So speakers, can you please just rotate the slides? So the third paper of this session is Understanding Quality in Declarative Process Modeling through the Mental Models of Experts. And the authors of this paper are Amin Andalusi, Christopher Davis, Andrea Buratin, Hugo Lopez, Thijs Slats, and Barbara Weber. Okay. So Amin will present the paper, and Amin, if you're ready, you can start.
Can you hear me? Can you see my screen? Everything
yes, we can see and hear you. Yes.
Okay.
Very good.
So welcome to our presentation. My name is Amin Andalusi, and on behalf of my co-authors, I will present our paper entitled Understanding Quality in Declarative Process Modeling through the Mental Models of Experts. So as you know, process models can be used for both enactment and management, meaning that we don't want models to be only interpreted by machines, but we want them to be also understood by humans. Process models can be modeled using imperative or declarative languages. Imperative languages, they describe the process executions explicitly, making them suitable for rigid and repetitive processes. However, when being used to model flexible processes, they often produce complex models. Alternatively, we have declarative languages. And declarative languages, they just specify the constraints guiding the overall executions, guiding the overall process, leaving any execution not violating these constraints allowed by the model. And this indeed makes them make them more adequate for to model flexible processes. However, with the increasing number of constraints in the model, this kind of declarative models, they can also get complex to understand. And here, our question is how to design understandable declarative process models. So as a first step to answer this question, we turn to the existing process modeling guidelines. And as you know, a lot of guidelines have been proposed. However, most of these guidelines have evolved from imperative languages. And indeed, their focal constructs are often not relevant to declarative languages. And this is because in declarative languages, we usually have concepts which go beyond what we already know from imperative modeling guidelines, like, for example, constraints. Moreover, existing process modeling guidelines can give rise to contradictions which could hinder the design of declarative models. And here, for example, is the case of redundancy. So existing guidelines for imperative languages, they recommend modelers to reduce redundancy in the model and rather sequence its activities. However, this guideline wouldn't work when modeling declaratively because first, this will influence the flexibility of the process, but would also require to add a lot of constraints to the model, which would in turn hinder its understandability. So to reduce these limitations, we must articulate the aspects defining the quality of declarative process models, and this is in turn the research question we are addressing in this work. So our approach is to address this research question is based on personal construct psychology. And personal construct psychology posits that individuals develop bipolar constructs that are scales to frame their experiences based on their similarities and differences. So in our domain, personal constructs could indeed be the scales used by the experts to evaluate or to judge the quality of a declarative model, and to infer these constructs from the experts. We provided them with process models grouped into triads, like what you can see here, for example, and then we asked them in what way any two models of the triad are similar but different from the third one, and why. And for example, by comparing these three models, one would say that models A and C are similar because activities are unicolored, so they all have the same color, while in model B, the activities are color-coded. And from this verbal utterance, we can infer the underlying personal construct or scale which was used by this by the person to make such an evaluation. So, for example, here the construct can be defined by the poles unicolored activities and color-coded activities. So in our study, we collected data through three steps. So first, we started from an existing process description, which is also documented in literature. And then we recruited the participants with different levels of expertise. So we had the novices, we had intermediates, and also we had experts. And then we asked them to translate the given textual process description into a declarative process model in DCR graphs. And as you know, DCR graphs is a declarative language which is used in both academia and industry. So after collecting the models, we asked 4 experts to participate in the personal construct elicitation procedure. So in individual sessions, we iteratively provided each expert with a triad of models, as I have shown previously. And then we have asked this triad comparison question, that is, in what way any two models of the triad are similar but different from the third, and why. And then from the answer of the expert, we could identify the underlying personal construct. And afterwards, we asked the expert to clarify the meaning of his construct, and also explain how this construct was used by him to evaluate the model. And we kept repeating the same procedure until we reached the theoretical saturation. And this is a stage where basically, even by creating new triads and comparing the models inside, no new constructs emerge. And here we know that we have actually reached this saturation. So the third and the last step was the repertory grid and the talkback. And here we have created a grid where the elements, as you can see, are the models we have collected from all the participants. And then we have placed, as rows, we have placed the constructs which we have obtained from each each participant. So also this step was conducted with each individual, was conducted individually with the experts. And here we asked the expert to rate the models in a scale ranging from 1 to 5 according to his or her construct. So this is an example of the ratings we have obtained for the different constructs. So afterward, we have analyzed the correlations between the different constructs. And for example, here we could see that the construct about the excessive use of exclude relations, and exclude relations are type of relations in DCR graphs, correlates with the construct about the clearness of termination endpoints. And once we have obtained these correlations, we asked the participant to comment on them and say whether they make sense and whether they have some more feedback to provide. And here, for example, one participant said that the correlation makes sense because limiting the use of exclude relations makes the termination pattern more clear in the model. And this is an example of the quality aspects we are reporting in our paper. Yeah. So by the end of this process, we ended up, of course, with a huge amount of verbal data, which was provided by the expert through all the steps. And to analyze this data, we listened to the recordings. Then we segmented and timestamped all the constructs and the associated insights we have obtained. And then we have applied a qualitative coding. And here we have used different coding techniques to group the quality aspects or the constructs first we have obtained from the participants into quality aspects based on their similarities, and then into categories and themes. So in this slide, I will just provide a short summary of the results, but I also invite you to have a look at our paper for more details about the quality aspects we could elicit. So we identified two themes of qualities. The first theme is about semantic qualities, and this is mainly about the behavior of the model. And then we had another theme about the pragmatic qualities, and this is more about the secondary notation and the layout of the model. And of course, within each theme, we had a set of categories, as you can see here in the screen. So and indeed. Within each category, we had these quality aspects which were inferred from the constructs we have obtained from the experts. So after getting to these results, we compared them with what we already know from the existing imperative process modeling guidelines. And what we could see is that most of the pragmatic qualities are shared with what we know already from the existing imperative process modeling guidelines. However, when it gets to the semantic qualities, we could identify some new or different aspects. So just to name a few, so with regards to modeling behavior, of course, the experts advised increasing concurrency in declarative models. With regards to modeling patterns, the experts said a lot, provided a lot of insights about how to use the different modeling patterns in declarative languages, but also they talked about how to treat exceptions in declarative models and how to show them clearly in the model using specific patterns. Other quality aspects were about the modeling of data, and this is mainly about how to encode decisions in declarative models, because as you know, encoding decisions is different in declarative languages because we don't have, for example, an XOR gateway or a similar construct. And of course, for more detail, I invite you to have a look at the paper. So as a conclusion, in this work, we were able to elicit the experts' meaning of quality in declarative modeling, but most importantly, we were able to show the potential of personal construct psychology in conducting similar exploratory studies. As a future work, we would like to discern the patterns characterizing the modeling of novices, intermediates, and experts. And then we would like to use these characteristics to profile modelers at runtime and then to provide them with the adequate tool support. Thank you for your attention.
Thank you, Amin. Let's thank the speaker and let's take a look for questions. It feels like we need more time for questions in general, so let's first look for questions from the audience. Okay, while we're waiting for questions from the audience, maybe I can ask a question. So I'm just a bit puzzled by this concept of comparisons that you do, like two are different from the third in one aspect or so. So how does this translate to the notion of understandability of the model? I was just missing this link. Can we maybe comment and explain this a bit more in detail?
Mm-hmm. So first we had we conducted this with the experts in DCR graphs, and these experts are researchers doing research, of course, in DCR, but also people in industry using DCR. So we assume that they know how to make so they have enough experience to know how to make understandable models. So they could also evaluate the kind of models. And through this, and basically the idea of this comparison process is to help them to articulate the scales they are using. And then we map these scales to the quality aspects. So for example, they would say that basically model like, for example, model 1 and 2 are similar because they allow, like, for example, a more flexible behavior, while model 3 is rather rigid and over constrained. And from this,
so I understand
yeah,
how that translates to differences. I'm just a bit missing this link to understandability, right, or understanding the model.
Yes.
Yeah. So these are aspects that people pay attention to, but
yes,
does it help understanding the model, right?
I think from the process we were also able to infer such insights. So as you can see here in the screen, so like, for example, one expert said, so after identifying the personal construct, the expert said that events in DCR can be assigned different colors. However, applying colors to events based on their assigned role is not helpful. It does not add any new information. And this is a kind of a quality aspect, which is coming by first identifying the personal construct and then initiating this discussion about how the construct is used to evaluate models. I hope this answers to your question.
That answers my question. Do we have a question from an audience? Everything was clear, everyone understood all the concepts. Actually, I just linking back to my first question, I was also puzzled with colors. Why did you include colors, right? Because, yeah, of course, colors is a visual aid for modeling. Mm-hmm. But if you start initially, like standards, notation standards, they don't introduce too much of color coding into the languages. So why you included the color from the very start in your studies?
Yeah, so the example of colors is just a very simple example to explain the procedure. But also it did in DCR. You can assign colors to activities, and from this work we could see that, like, assigning colors to activities can be confusing because they don't have any semantical meaning. So depending on the reader, you can make different interpretations of them, and therefore it is recommended to avoid them as much as possible.
All right, then if there are no further questions, let's thank Amin once again, and I propose that we move to the next paper. Thank you, Amin. Okay, so the last paper of this session is entitled How to Keep RPA Maintainable. This is a paper by Philip Noppen, Aris Bireput, Inge van der Wert, Matthew Jonker, and Hayo Ryers. and Philip Noppen will present the paper. Philip, if you can.
Yes, thank you for the introduction.
Thank you very much, Philip.
Yeah, so welcome to the presentation of regarding the paper how to keep RPA, robotic process automation in short, maintainable. So my name is Philip Noppen, and I will be giving the presentation on behalf of our team. So to start off, RPA is a term for software tools that operate on the user interface that try to mimic a real user. RPA is non-invasive to the underlying IT infrastructure as opposed to BPM solutions. RPA is used to automate processes that are structured, rule-based, and repetitive. So let's look at an example. In this example, a bot is tasked to create an invoice. Creating an invoice is a typical use case for RPA. To fulfill this task, different applications have to be accessed. For instance, data is retrieved from an Excel sheet and then entered into SAP. And herein lies its main strength, which is to connect all these different applications. If you were to opt for traditional automation for these kinds of processes, it will be more costly, more time consuming, and you will encounter more risks, such as changing requirements halfway throughout the project. Having said that, RPA is just one way to automate a process and is by no means a magical solution that can be applied to any process. So organizations that aim for quick wins to save costs are eager to implement RPA. That is because bots are relatively quick and easy to build. After a relatively short period, RPA starts to spread beyond initial experiences. At that point, the issue of governance comes up, which will be further discussed in a few minutes. So regardless of governance structure chosen, organizations must face the problem of an increased burden of maintenance once RPA is scaling up. Maintenance efforts are often higher than expected, and therefore maintenance can be challenging to a lot of organizations. This brings us to our research question. How can organizations minimize maintenance problems related to RPA implementations? To answer this question, we present the set of 11 guidelines for the creation and sustenance of low maintenance RPA implementations. Before we move on to the governance structures and the guidelines, which is the most interesting part, of course, I will first explain how we ended up with 11 guidelines. So we started out with a literature study containing gray literature, such as reports from RPA vendors and consultancy firms. From this literature study, we derived a set of 29 preliminary guidelines. And we proceeded then with a multi-case study at 4 organizations to gain additional practical insight. 2 organizations operate in the finance industry, one as a large Dutch bank and the other one is a smaller private bank. The third organization is a large postal and parcel organization operating mainly in the Netherlands as well. The fourth organization is one of the largest municipalities in the Netherlands. One of the organizations was just starting with RPA, while another one had already made significant progress and had already scaled up. The other 2 organizations were more or less in between. After the case study, we could classify the guidelines as confirmed at one or more of the case organizations, and we could classify them as only coming from the guidelines or as guidelines that were only found in the literature. The final phase was to validate these guidelines using a Delphi study, and more specifically the Policy Delphi. The Policy Delphi is an instrument for policy development, which is the goal of this research in the format of guidelines. This distinction needs to be made since the purpose of the Policy Delphi is not focused on establishing consensus among experts. It's more about clarification of divergent views, generating policy alternatives, or decision making on them. Furthermore, it can be about estimating the impact and consequences of any particular option, or examining the acceptability of a particular option. The Delphi study had a relatively lightweight interaction, as we used an online survey to get feedback on the guidelines, and the experts were able to leave comments which were then further used to refine the guidelines. The experts were selected based on publications related to RPA. They were working mostly in academia, but also in the industry. Finally, we narrowed the scope by including only those guidelines that are relevant to organizations that have adopted a federated model and contribute towards achieving maintainability in terms of their RPA solutions. I will explain the rationale of the scoping on the federated model in the next slide. So at the end, we ended up with a set of 11 validated guidelines. Once RPA starts spreading beyond initial experiences, organizations start setting up a governance structure. Organizations have roughly 3 choices or can choose a combination. Large organizations can opt to have a few departments that are federated and one department that is centralized. This was also observed at one of the case organizations. Organizations that opt for a centralized structure establish a center of excellence containing the entire RPA development capability. Within such a center, there are project leaders who are responsible for multiple smaller automation teams. These project leaders play a role in identifying, designing, and implementing RPA use cases within various business units. The employees within these business units that are tasked with the processes to be automated are closely involved as they are the subject matter expert. They possess all of the process knowledge and their knowledge can be further used to identify and prioritize new RPA opportunities. So let's move over to the decentralized model, where the RPA capability is placed in different business units without a governing body in place. This option seems to be the most chaotic and less efficient, which is true, but it still has its advantages. So first off, it creates enthusiasm for digitization, as regular employees within these business units are deeply involved and they have full ownership. However, this comes with significant downsides. There are no control mechanisms to coordinate and prioritize different initiatives, which affects quality, and there's no perspective of the bigger picture of how the process are part of or affect other parts of the organization. So the federated approach combines the strength of both the centralized and decentralized structure. It retains the benefit of local ownership and business involvement, while the disadvantages of the decentralized approach are avoided by adding a governing body in the form of a center of excellence. Furthermore, adopting a federated structure spreads out the maintenance effort more evenly across the organization. However, the overall amount of maintenance necessary can still be more burdensome than initially expected. When purely looking at the burden of maintenance, a federated model provides the best starting position to tackle this issue, which is why we narrowed the scope of the guidelines and have them aimed at organizations that have adopted the federated model. Organizations that have scaled up using a centralized structure and are starting to struggle with maintenance are advised to consider transitioning to a federated structure. This brings us to the first guideline, which is to consider enabling business units to develop and maintain bots if they are deemed sufficiently capable. So what I mean by sufficiently capable is that they have a moderate amount of IT affinity and are committed to building bots. One interviewee at one of the case organizations really highlighted the importance of intrinsic motivation, being interested in this new piece of technology and to really push themselves to learn new things. It is a learning process, and training and mentoring on the job facilitated by the Center of Excellence should be sufficient. A robotics team within a business unit can be set up with the help from the Center of Excellence, who aids in recruiting qualified people within that business unit who are able to work with the RPA development tools. If a robotics team still lacks the required expertise to develop bots, that business units can be temporarily extended by an expert from the Center of Excellence. So the next two guidelines are closely connected and concern quality control during and at the end of the development phase. The first guideline says that quality checkpoints should be implemented during bot development to audit the usage of RPA development standards. This is done to prevent an accumulation of issues that is discovered during a technical review by the Center of Excellence at what is supposed to be the final phase in development. The next guideline is closely linked to this guideline. So the second guideline is about performing a technical review once a bot is considered finished by a business unit. This is done to ensure that a bot is up to a certain standard defined by the Center of Excellence and is ready for a live environment. One of the case organizations plans to impose quality checkpoints during development and during the final sprint. The goal of the quality checkpoints, as they stated, is to ensure that development guidelines are used to prevent the need for rework in the future. And more specifically, the bots are reviewed in terms of reusability of components, robustness, testability, and resilience to future changes to reduce the risk of vendor lock-in. So the last guideline that is part of this presentation involves suppliers or customers. This guideline states that organizations should consider promoting RPA and share RPA-related knowledge with suppliers or customers. Organizations willing to do this can already start when they are about halfway scaling up and can be considered experienced in RPA. The rationale behind this guideline is that a bot may rely on external information sent by a customer or supplier. Such information needs to be highly standardized and uniform in all cases. Automatically generating documents such as Excel sheets using RPA can ensure that every sent Excel sheet adheres to a certain set of standards, bearing failures, of course. As a result, promoting and sharing knowledge related to RPA could have a positive effect on RPA adoption at customers or suppliers. And this can contribute to further standardization of the entire chain of linked processes, leading to less maintenance and leading to fewer exceptions. So to recap, one of the most important choices for organizations that they have to make is choosing a governance structure. Implementing a federated structure has its advantages over the others, but it does not guarantee success. Organizations are encouraged to review their plans and account for the issues that we describe. They also may want to investigate the capabilities of their business units. We hope that organizations that have already deployed RPA and are currently struggling with maintenance issues can use these guidelines to relieve their maintenance burden and improve the overall quality of bots across the organization. That's it. Thank you for watching and feel free to ask some questions.
Thank you, Philip. Thank you very much. I pass this applause from the whole audience to you. Do we have any questions from the audience at this stage? So please type in your questions in the chat or question and answer function of the Zoom. Maybe I can start. I have actually not a question, but rather an observation or a comment. You know, I'm a bit familiar with the studies of different architectures in data warehousing. And there they also have the concept of federated data warehousing, but then they refer to this federated architecture as the least advanced architecture, I would say. It's an architecture which is composed just in an ad hoc fashion out of all those components that exist in the organization. But you refer to it as the most advanced or most sophisticated one. Optimal. Yeah. So what is the background of this terminology here? Why federated?
Well, what the background of this terminology? So to start off, there are three approaches, and one is the federated, and the advantage is that it combines the strength of the other two. It combines them in one package. If you look at it from like a governance standpoint, if you take the United States for instance, all these business units, they are individual states, and the governing body is the RPA Center of Excellence. So if this Center of Excellence is performing well and leads, then the individual business units, they can really benefit from that. And within these business units, these development teams that are made up of just regular business people. They can take advantage of all the knowledge, of all the strengths, of all the expertise from this Center of Excellence, and they can apply it to build better bots. I hope that sort of answers your question.
Yeah, that makes sense. Yeah, to some extent, yeah, it makes sense. Right, just collecting the pieces on different level of granularity, right? Either from the components scattered across the
certainly reusing components, but that's certainly a part as well.
Let's check if we now have questions from the audience. The audience is quite passive today in this session. We have questions. So maybe I can then ask another question. So what are those guidelines that relate, because we also do research in RPA, and that's interests me the most. Are there any guidelines that are concerned with replacement of, let's say, outdated scripts, or somehow go in that direction of, well, life cycle management for the RPA? So what are those specifically?
Yeah, that's a good question. Well, in terms of life cycle and really developing these bots for a longer period, we discuss a bit of using development standards, but also certainly about reusing components. So if you use the same components for multiple bots, and then if something changes, you only have to adapt that one component, and then you can apply it to all these different bots that use this one component. But there are no guidelines about bots that are well, not necessary anymore because of, well, changing requirements or changes to the organization. But I have to address that some of these bots are just built for just a small task, such as exporting data from a system that doesn't have an API in place, which was one of the use cases that one of the organizations used. So they just built a lot of bots just to extract the data from one of their systems.
Hey.
Oh, really?
Yeah, there's one question in the Q&A. For me, it only shows anonymous, so I will read it out. Yeah. So, what is the main consideration that a company should make before they make the decision to use RPA in their processes?
Okay. Yeah. Good question. Well, it's difficult to point out just one consideration, but yeah, I think still the most important consideration is to really write down what you want to achieve with this technology. As it can be a really good and a very strong technology, but you have to really know what you want to achieve with it. I think that's still the most important one, and then you have to think, how should we implement this technology? How should we use it? Because if it all depends on the use case. So if you plan on building or if you plan on automating a lot of processes, it's really important to first set up a really good infrastructure, really good starting structure to start developing these bots, so that in the long run you don't run into certain issues that can pop up when using a decentralized structure. So it all depends on your use case. And if you only want to start small and only want to automate a few processes, yeah, it does not really matter what kind of infrastructure you choose.
Okay. And there's another question by Kamal. Maybe you want to ask it yourself?
Yes, good morning. So it's Kamal. Thank you for your presentation. So you're presenting the centralized, decentralized, and federated. So I added a link in network theory or network practices. We have centralized, decentralized, and distributed. So maybe you mean in federated is decentralized with more characteristic, and that's my question. That's my note. That's all.
Yeah, certainly. If you remove the center of excellence, you basically have a decentralized structure. That is certainly correct.
Okay, thank you.
Okay.
All right, then I propose to conclude the session. We ran a bit over time, but we started a bit later, and I want to thank the speakers for keeping up with timing. Timing was perfect from the speakers. So let's give a round of applause. Those who can, please unmute and join me in this applause. Well done. So I encourage everyone to follow the program. We still have a lot of interesting things today. Industry Forum Session 2, Tutorial 3, keynote on how to infuse AI into business processes. So definitely a lot of interesting things to follow. I thank you once again, everyone who joined the session. That's the end of it. Thank you very much.
Thank
Bye-bye.
you. Thank you. Bye.
You.